Oh, I don't know any algebra, so if it has anything to do with that, I forgot.
It doesn't.
I don't think it's really
But
algebra.
for me, I'm
So
going.
why 6 times 6?
Because there's six sides to each side.
There you go.
Right?
That's it.
Yeah.
That's
But
it.
if you explain to me that 6 sides to a side, so therefore I multiply by 6, but why?
Are we
you got
talking
two
about
dice.
the
Oh,
how many
six
sides,
sides.
or are we
I
talking
understand.
about the exact number
But
on the
there's
die?
6 on one and 6 on the other. That's
Yeah.
Well, there are
So,
6 sides, right?
those are
It's
the
1,
top-
2,
those
3,
Are we
are
4,
the
5,
talking about the
6.
side?
The actual
Oh,
numbers.
The actual
I
number on
1,
the
2,
die?
3,
if
4,
you-
5, 6. And
Okay.
then 1, 2, 3, 4, 5, 6.
Yeah.
Right? So tell me, I'm going to do this, and some of you go, that's where you come from.
You know
So
what?
let's say this is
I got.
row
I can pull this
1.
up for everybody right now.
Row 1.
I know, we had
Do
yours.
it. Yeah,
Okay,
see, she,
row one,
she
row
knows 'cause
two.
she was in my class, so.
So I want to tell you why it is. There are many ways of doing it. Okay? If I roll number 1, so there are, can you see that there are 6 ways to roll the first dice? And then there are 6 ways to roll the second die. Right? All of them 6.
Oh, can you teach me?
Okay? So if I roll 1 and 1, what is my total?
1.
Oh,
1 times 1.
Some. Huh? 2? I wish I had another color.
I have dice.
Oh,
Ooh, she has
no
dice.
way.
You don't need it.
No way, really?
You need to, because on the test you can't bring it with you. You can't bring it with you.
So smart.
So if I
You
roll,
gave me those, remember last semester?
Bang it.
so if I roll 1 and I roll 1, what is my sum?
2.
2. If I roll 1 and 2, what is my sum?
3.
3.
Okay, 1 and 3,
1 and
4,
4. 1 and
5,
1 and
6, 7. What is the next roll? I roll 2 and 1,
3.
3,
4.
4, 5, 6, 7, 8. Okay?
So
4. Now, there's an easier way to do this, but I'm
Wait,
going to do it
how are
just to
you
show you,
getting
right?
8, 9?
because
3 and 6.
yeah,
So are we just
if
direct
you roll
multiplying in
if
this
you roll the
situation?
3, you
No,
get 6, you get 9.
Forget about how you do it right now. I just
I
want
want
you
to
to log.
visualize and see how, where
Right.
you
Forget
come
about the
from.
multiplication. I just want you to see where that comes from. You
Yeah.
logically have to understand that when you roll a die, that depending on your first roll, your second roll, you multiply that, you add that number, right? So I can keep going, right? Does everybody see that? There's a pattern here.
No, it doesn't get smaller. But I can actually.
8, 9,
Send it to
10, 9,
You got Google?
11. What is the highest number I can get?
Because it's
36.
No.
12.
What is the highest sum I can get when I roll 2 dice?
12.
12. The sum. I'm not saying. Okay. So where does the 36 come from?
The possibility
Does every-
The problem, yeah.
So think about it. When I roll 2 dice, there are 36 ways that this could happen.
Because right now, it's 36 numbers up there right now that y'all
Right.
looking at.
That means that there are 36 possibilities.
Oh, okay.
Those are
That's
36
okay.
numbers.
There are 36 possibilities.
So,
That's where the 6 times 6 come from.
okay, so when I roll this, there's 36
Possible ways.
It's,
that I could get.
That's right.
if you see it, it'd be,
Right.
see the numbers too, then you can fix it.
Right. So does everybody see? So if you forgot how to do it, oh, you're shaking your head. So I want to make
I
sure you
didn't see,
understand.
yeah.
Okay.
Enough to see.
So how many ways are there to roll 1 and roll the other one? 1, 2, 3, 4, 5, 6. So
Yes,
if I have 1, I have 6 other ways of getting the other one.
yes,
If I have 2, I have 6 other ways.
yes.
Now I have 12 ways. If I have 3, I have 6 more ways.
Mhm.
So altogether is 6 times 6. 6 times 6. Does that make sense now?
Makes sense.
Yeah, it's not magic, right? The 6 times 6 come from something. That means there are 6 ways. That means if I fix 1 and I keep rolling,
Yeah.
right? There are 6 ways. If I turn it and then roll, there are 6 ways. So there are 6 times 6. Okay? Another way to think about this, okay? Again, you can just remember the multiplication, but sometimes you panic. The other way to think about it is dice 1. Okay, I have 1, 2, 3, 4, 5, 6. I'm not doing this very pretty here. Okay, for each one of them. So this is no, this is start. Start over. Start. Again, this is organizing your thought. I don't know how many of you have seen this. This is another way of thinking about it. So this is die 1 or row 1. Okay, I'm going to go row 1. So for row 1, what are my possibilities? 1, 2, 3, 4, 5, 6. What happens if I get 1? How many possibilities is it that after I get 1, I can do row 2? Same, right?
Because it's just one dice. It's always gonna be the same with one dice, or one die.
See that?
Say one dice.
When I roll it once, so whether you roll it together or roll it separately, it's the same problem, right? Because it's about how many possible ways can you have 2 dice when you add the numbers. So do you see how if I think of it this way, which is the same as the table, you eventually, also add up to,
So there's 6
36.
times 6.
right?
Yeah.
Either one
That's
give you
This one
36.
makes sense to me than that one.
That's
I
fine.
was less on the other one, but
Okay.
this one I get it.
You get it, right? But you got to think about it though. I'm talking about the sum, right? So what is the sum between 1 and 1? It's 2. 1 and 2 is 3, right? 1 and 3 is 4. In here, I'm going to have to do this in my head to know what the sum is. The nice thing about this one, I already added it up, right? So if I ask you, how many possible ways to get 12? What would you say? Logically, how many ways can you get 12?
1 out of 36.
There you go.
Right? Because you have to get 6 on one, you have to get 6 on the other one. And there is only one way that happens. Okay? How many ways are there to get 11?
2 out of 36.
2 out of, and what is it? Either 5, 6 or 6, 5. Okay? How many ways are there to get 10? 3 out of 36. Okay? 3 out of 36. Okay? Yeah. How many ways to get well, 2 is easy, right? How many ways to get 2? 1. Because you have to get 1 on 1, you have to get 1, not 1 out of 36, right? So that's why it's hard to get 1 out of, to get 1, because you only have 1 chance out of 36 chances, right? Whereas if you think about 5 and 6, look at that. There's a bunch of 5s here. Look at 6, right? 1, 2, 3, 4, 5 times.
7 is the best.
Right? 7, 1, 2, 3, 4, 5, 6. 6 times.
1 out of 6.
Yes. Right? So if you think, if I ask you which is the most, which sum is has the better chance that you will get?
7.
7. Okay? That's why in games people say, oh, you want to get a 1? Good luck, right? Good luck. Right? Because you only have one way to do it. There's only one way to do it. 12 is another hard one. There's only one way to do it. 7, so many ways. 2, 5, 3, 4, 4, 3. Right? That's why when people roll, you get 6 and 7 a lot. Try it next time.
That's why you don't gamble in the casino.
Yeah,
Right
so
there.
that's what the amount.
The probability you hit the 7.
Is this making sense? So I didn't want to just talk about the multiplication. I want to talk about the logic of it. Right? I want to talk about the logic of it.
Possible number to get that number.
Okay?
That's what I first said when I was doing 12.
So, let's get back to the question. It says, what is the chance oh, here you go. So if I ask you, what is the chance, what is the chance of getting a 2 or getting a 3? What would you tell me?
For 1 or
Getting a 2 or a 3?
What do you mean?
Out of how many die?
Yeah, that's,
This one, 2 dice. I'm talking about the same problem.
112.
2 or 3.
2 or 3 is
112.
112 for 3 and 118 for 2.
So if I circle, would be what? This one,
Yeah.
right? This one, and this one. Does everybody see that? How many of them is out of the whole total? 3 out of 36.
36.
That's the 112. That's where the 112 come from.
Oh.
You
Okay.
use the word or.
That's right. Now, I didn't care whether I add or subtract. I just want to know if, listen to the question, right? I say it could be a 2 or it could be a 3. That means I got to circle 2 and I have to circle 3. And I just count them. So when you start counting, that's an add, right? You add. Now, the reason the multiply works, let's try it, right? Let's say, what it would be when there is a multiply? This is, okay, I'm trying to think what would be a multiply one. Somebody did it earlier. You did the multiplication instead of counting.
You did?
Yeah, somebody did that earlier.
What, the 6 times 6? That's,
Yeah, how did you do this? If you did it by not the counting?
if we,
1/6
you have
times
to
1/6.
count. Huh?
1/6 times 1/6.
I mean,
Oh, it's because you have the 2
Oh,
die with
yes.
the 6, so it's 6 cubed. 6 and 6.
oh,
Yeah, I think I'm trying to find a question where you multiply. See, I don't even think of multiply or divide. I just think about what the problem is asking me to do. Okay? So let's try this.
yeah,
Yeah, let's try another one. I know, I don't want to like force a problem into that because I want to leave it here for you and think about it. So if I ask you, so my question is there an easier way? Is there an easier way to do this problem without having to do the 36 written out like this? There is. I might actually complicate it. That's why I don't want to do it. Because what you're saying is that in order to get 3, I know that it is 1. The first one has to be 1, or the first one has to be 2.
In order to get what?
To get 3. So I don't want to do that part because I think I want to leave it this way so that you can see it and then listen to the question and see what the question is asking. Okay? So let's try the problem at the bottom, 13. When you have a die and then you have a coin. Okay? You have a die. This is easy, right? Because on both sides it's exactly the same thing. So let's try it when one is a coin and one is a die. And we're going to use the same method. Okay? Whether it's a table or a tree. Okay? This is like almost like a, I don't call it decision tree. So could somebody read that part, the last part? I know it's an and, but we're going to actually do it. We'll actually do it. It says,
Other events may consist of 2 sub-events. For example, a die can be rolled and a coin can be flipped. What is the probability that a 5 appears on the die and a head appears on the coin? The word "and" is important to this situation. It determines that the 2 separate probabilities are found and then are multiplied to give the overall probability.
so forget about that. Forget about the multiplication. Let's say you forgot the and or the mutually is whatever. For probability problem, I like to write out all the possibles. So how would I do that? I have, what is it again? I have a die, is that right?
Yeah?
I have a die, and then I have a coin. All right, so a die, so if I start, a die could be 1, 2, 3, 4, 5, 6. Yes? Yes?
Yeah.
And if I get the die 1, what are the possible for,
Heads or tails, two different ones.
yeah, right? You could have head or tail. Can you see that for each one of them you could do that? Right, so these are your possible.
Okay.
Okay, so what is the question asking you?
Probability that a 5 appears on the die and a head appears on the coin.
Okay. So, can I circle the part that they want?
Yep.
5. So how many possibles are there?
12.
Can you see that it's 12?
There.
Because for every one is.
Yeah, for every die there are 2 possibilities. So that's why it's 6 times 2 is 12, right? There are 12 possibilities. And how many of them is a 5 and a half?
1 dice.
1.
Yeah, 1 out of 12. I didn't do any multiplication,
No, I mean,
right? But you could, okay? The reason you could is because what is the probability of getting a 5? 1 out of 6, right? And what is the probability of getting a half?
1 out of 12.
half.
And that's where the 1/12 comes from. So you could do it this way. It's fast,
Yeah.
but you know what, when I panic, I like to at least draw it to make sure that it's right. And it's, I mean, the problems are not gonna actually draw 50 things. It's gonna be like heads and tails, dice, right? So something like 6 things and maybe a coin, there's two things. They're not gonna ask you to say, we have like 7 possibility and then 12 possibilities there, okay? It will be simple possibilities where you want to understand the logic. Because you know what? They will give you answers that are like, oh, it's 1/6 plus half, right? They will give you the answer, 1/6 plus half. But if you drew it out, you know that there is 1 possibility out of the 12. There's only 1 possibility when you get a 5, and then you get a half. There's only 1. Now, you could do this with this table too. So if I do this table, it would be, let me see how I can do the table here. Every table is actually, for this one is actually very easy, right? If I could go, how did I do that? So 1, 2, 3, 4, 5, 6, and then this is head and tail. So the possibility, this is 1H, 1 tail, 2H, 2 tail, 3H, 3 tail. Okay, so those are 2 exactly the same way of looking at the same problem, right? That I have a die on one side, and then I have a coin on the other side. Okay, so when you write them all out, guess what? 5H is also 1 out of 12 possibilities.
And then in the questions, so or means add, and means multiply.
Yes. But I often don't follow that because I like to draw it out to make sure.
But
What
we
if
don't
I
even
panic?
have a lot of time when we're
I
doing
know,
this, right?
I know. So you learn to read the problem to the point where you get that, well, between a coin and a die, I have 12 possibilities, right? Because it's 6 times 2, right? So you know that if it is an and, then you know that you can multiply, right? But here, it's a little bit more difficult, and that's where if I say 2 and 3, what is the probability of getting a 2? 1 over 36. What is the probability of getting a 3? 2 over 36. Because it's an or, right? That means I'm choosing all of those. Okay. So that's the difference here. That's the difference. But you want to practice drawing because you want to practice understanding, and then the multiplication and adding will make sense. Because if you only go to the adding and multiplication, you don't have the foundation to understand where did the 36 come from, where did the 12 come from, right? I mean, if you only memorize it, you're gonna add wrong one of these days, and then they're gonna show you the one that you added wrong, and it will be on B, right? And you choose it, and you realize, wow, I didn't even do this. Yes, you may not have time, but if you do a little bit, say, oh, I got it, I think I'm remembering this problem, right? That 6 times 6 is 36, yes, 36 possible.
I mean, this is the time, sorry, after you're done, if you can find time,
The last one? Sure, sure, absolutely.
On page 15, did you
15?
take those at all or not?
Yeah.
They're really easy, they're not hard at all, there's actually nothing to do with some of them.
Which one?
Just
Which
give
number?
Different examples. Black cards, could be 2 cards.
Right, could be cards, right? Cards could be one, cards and die or something could be the problem, yeah. Yeah. Do you want me to do that, or do you want me to let you guys try it?
Keep
I'm gonna
going,
look at-
you can keep going. It's
I want to
really-
look, yeah. Let me see, and you have the answers too, so that helps. Let's look at, page 23. There's a whole section here called, oh, I need to make sure that you guys understand about, so let's look at, this is good. Let's look at page 21, question number 1.
this is 21.
21, number 1. That's less about a probability problem, more like what they call, yeah, I guess it's a probability. So it's like how many ways can you have committees, right? Right, it's a permutation problem. Yeah, trying to figure out how many ways you can combine something. Like I have 3, for example, there's a problem that's actually real in the textbook. 3 flavor of ice cream, 2 flavor of toppings, and two types of cones. How many possible ways can I choose what I want, right? For a combination of the sundae that I want, or the ice cream cone that I want. So that's kind of different problem. You have a corporate board of 12 members, 9 men and 3 women. Wanted a 2-member committee to study the gender opportunity committee. How many different committees could be formed, containing 1 man and 1 woman? How would you do that?
So this is pretty similar to the die question, right?
Exactly.
Because you've got 9 men to start off with.
Yep.
And each man can have 3 potential different women.
That's right.
So
That's right.
9 times 3.
That's right. You got it? Yeah. Yeah.
I need explanation.
Yeah, okay, very good. So that's a great connection, right? It doesn't have to do with die. It doesn't have to do with coin. But you do have 2 different kind of people. How many men? 9 men and 3 women, okay? So I could do it both ways. I could say, for the men, again, I can do a start. Okay, some of you actually like this because it's logical. Men, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Then for each man, you can pair with how many women? 3. So that means for each man, if I pick man number 1, I could go 1, 2, 3. Right? For each one here, I could go 1, 2, 3. So without doing it all, how many possibles there are?
So each man can have,
No, you're gonna form a committee of 2.
27?
okay.
Yeah. That means if you can think about it, right? There are 9 men with 9 names. Okay, 9 men with 9 names. You have 3 women with 3 names. And if I want a man and a woman, how many possible ways can I do it? Right? You could have the man number 1, let's say Alan, can be paired with Jill, Sally, Rose.
2-member committee, okay.
Right? 2 men committee. So you can think about how it's committee member 1. Maybe that's what you think. Number 1, committee member 2. Now you could do it the other way too. You could start with women and go to the men. You still get 27.
Oh, so there would be 27 different committees formed.
Possible. It always say is how many possible ways you could form it. Read the question. All it's asking is how many possible.
So at the beginning of the corporate board with 12 members, which means this is just the total number of men and women.
Exactly.
Okay, I
That was not
understand.
even necessary.
Okay,
I don't care.
understand
I know. Sometimes they give you extra information.
that. Why they do
Yeah. There are 12 people.
Yeah, okay.
And what you're saying is that if there are 12 people, how many possible ways that I can,
Make a question like this. It's confusing for me.
It's always the way that the word, that's.
Right, it's always the wording.
It drives me bananas.
I know. But in real life, that is real, right? There are 12 people in the room.
Yeah.
There are 9 women, 9 men and 3 women. So if I want to pick a committee of 2, I'm going, oh my God, there are a lot of combinations there. There are 27 combinations. Okay, there are 27 combinations. Now, why might you want to know there are 27 combinations?
Say that again?
Why would you want to know that there are 27 combinations?
Between what?
Why would you want to?
Why would you want to know that there are 27 combinations? How might that help you as somebody who's trying to form this committee?
To see who works best with each other.
Yeah, it could be, right? If I were to actually put names on this, you know, Ellen, right? Ahmad, right? And then Scott, right? William, Abdullah, right? I'm gonna put all these names now. Chang, right? So let's say I did this, and I actually wrote down all the combinations. I might, like you say, I might kind of go, oh, these two never get along, right? I might never want that combination, right? I'm making this reason up, but what I'm saying is that you didn't do the math just because somebody asked you. People actually use this kind of methods to figure things out, to figure out what the combinations are, what are the possibilities, right? If you think about children the same way, if you think about what combination of the cone and the ice cream and the flavor, well, some combinations might be better than others for the kid because of allergy, because of, I don't know, something, right? Maybe the color. Okay. There might be some color that doesn't look so good.
Well, I got right for number 2.
Good, good,
Wow.
good.
I just multiplied.
Yeah, because guess what? After a while, you can see it, right?
Yes,
You don't even have to do it. But if you want to do it, if you want to get started, once you start, you go, oh, I got it. You
Okay.
multiply, right?
The key is really understanding
The question.
The question.
Right. Probability and statistics, there is nothing hard of the math. It's mostly multiplying and adding and interpreting data. It's about understanding what the question is asking. Right? You're not doing an equation. You're not doing like terms. You're not doing like, what did we do the last time? Like isolating anything. You're not doing any of that, right? All you're doing is trying to understand what the question is asking you. And logically, why do you multiply? It's because, guess what? Guess what? Multiplication is really a simpler way to do addition.
Yeah,
Right?
Uh-huh.
You're grouping things. That means I could count one at a time. Or I will like, wait, there are 9 groups of 3. That's 27. Right? Right? So multiplication is really adding. It's just an easier way to add because you're grouping things together. So when you think about probability, a lot of the multiplication has to do with the fact that I can imagine the 27. You could write them all out, but you can imagine it because it's groups of 9 of 3 or 6 of 7 or whatever that might be. Yeah. Your question?
So on these questions that change the probability to a percentage,
Ah,
I'm looking at number 9 that I can't figure out on
Which
page
one?
17.
page 17.
And actually, just while we're looking at that, like number 6, it says a number from 23 to 35 is drawn at random. I don't understand how to even calculate that, because what is it drawn from? And how do we make a decision like that? Because it doesn't say anything.
What number? You said again?
Number 6 is
six?
my question in number 9, because I can talk through how I figured out 9, but it didn't come out as the right question,
Okay.
answer at all.
Where is the question?
Oh, okay.
The question
Number
is on page
17.
15, isn't it? Or
17.
No, number 17.
Oh, I see, got it. Yeah, you get a little confusing here. right?
Number 17?
On
No,
page
it's on
17,
page 17.
there is a problem
Number
called
6.
Well, number 6, I want to know where are we drawing it? I mean, how do we
Okay.
calculate that if it's drawn at random from what? Does that
Okay.
matter?
Yeah, it actually says from 23, so in between, so the number 23 and 35, that's the numbers that you're doing.
Ah.
So do you understand how I read
Yes.
it? Okay.
Yes, I know
Okay.
it, yeah.
And then the other one is number 9 down there. It says a jar contains 10 purple, 15 yellow, and 13 red marbles. So I calculate that as at 38 marbles total, right? A marble is drawn at random.
Yeah.
So what is the
Yeah,
probability
what's
that
the
is
probability
yellow?
that you'll get a yellow?
So my thing was I put 15
Yeah,
over the
you would.
38, but that is not correct because they say it's 39%, which I don't know how you would find that from 15 over 38.
You add.
So how do you convert a fraction into a percent?
Divide
Divide it.
15 by the bigger number to get the percentage.
Right, would you do, okay, let's say that you actually got this in the test, right?
Yeah.
Your number is a fraction, but everything on that test has no fraction on it. The A, B, C, D is all percent. So what would you do? 15 over 38, is that what you got?
Uh-huh.
So let's say, then how do I make it into a percent?
So you divide 38 into 150, which
Or
Generally-
38?
by 40, 150 would be 3 times because that would
Uh-huh.
be
24, 3 times 3 is 9, 11. Did I get that right? Did I get that right? I need to put a dot here, right? Because 15 is smaller. I know it's less than half. Can everybody see that? I know that the percent of this is less than half. So in a lot of ways, I don't even need to do it. I just need to know that it's less than half. I know that it's less than 50%, right? This is less than 50. Does everybody see that?
anything that helps me. This
Does
helps
that-
me.
Okay?
Because I would not know what to do, even though I was looking at it and when you tell me right
Yeah.
now, it's obvious, but I just
Yeah.
was like,
So just remember what I say. In math, there are many ways to represent the same thing.
many
Right?
ways to skin a cat. No, sorry.
I hope there are no vegetarians in here.
I am, don't worry, and I'm a crazy cat.
But you know what I'm
too.
saying?
Yeah.
You got this, and if your answers have no fraction, you're gonna have to convert the fraction into a decimal, right? Now, to convert the fraction to decimal, you divide. But there are times where I can look at the answer and I go, oh, it's definitely not 75%, right? I know that it's not 75, so I take that out. I know it cannot be, it is not that close to half actually, but I know that it's gonna be less than half. So if you